Okay, so as in the last class, we have discussed about the four states of matter. Those were solid, liquid, gas, and plasma. And today we'll be going with fifth and sixth states of matter, which are basically Bose-Einstein condensate and Fermionic condensate. As you can see, I have written here. Alright, and these both states of matter we can get in the coldest temperature. I mean to say of minus 273.15 degrees centigrade, which is also known as absolute temperature. Alright, so let me make an arrow here. These both states of matter we can get in coldest temperature. Alright, so now let's see how this Bose condensate is made. Right, Bose-Einstein condensate, or we can simply say Bose condensate. How this state is made. Alright, as we know, this is the fifth state of matter, and this is also known as superatom. This is also known as superatom. I'll be telling you soon why this is known as superatom. I'll be telling you that, no worry. But this state of matter we can get in the temperature of minus 273 degrees centigrade. Let me write that. In the temperature of minus 273.15 degrees centigrade. Alright, so now basically we have to take a boson atom, just because as we are going to make the Bose matter. For making the Bose matter, wait, let me write here, we are going to make Bose matter. Alright, for making the Bose matter we need to take boson atom. Alright, for making that we need to take boson atom. Wherever on is coming, you need to understand that that is a very smallest particle, boson atom. Alright, which means it is very smallest atom. Now what is this boson atom? All the elements which have, the addition of electron, proton and neutron is even number, that is known as boson atom. For example, if I am taking helium, we know that helium has 2 electrons, helium has 2 protons, as well as helium has 2 neutrons. When we add these all numbers together, what do we get? We get 6. And what is 6? 6 is the even number. Alright, thus we can say now helium is a boson atom, just because when we have added electron, proton and neutron of boson atom, we have gotten 6, and 6 is actually an even number. So helium is a boson atom. So now we take, boson atom here in very low density. This is important point which we need to write. Low density means there would be only 3 or 4 atoms, boson atoms. For example, 1 here, 2nd here, 3rd here. So these are basically 3 boson particles. Alright, so now we know that we need to decrease the temperature, just because we can get this Bose condensate in the only lowest temperature, which is minus 273.15 degrees centigrade, which is also known as absolute temperature. So now we have to decrease the temperature. Now this is the decreasement in the temperature. So basically this is, you can get minus 1, minus 10, minus 100, minus 200, and finally here minus, these are basically minus. So minus 273 degrees centigrade. These are degree centigrade, degree centigrade, degree centigrade and degree centigrade. So are these particles have reached here now? We know that there is a characteristic of particles, that these particles will have what? They'll have momentum. Momentum is the product of mass and velocity. It is basically product of mass into velocity, which is represented by p. Alright, so these particles have momentum. This momentum was high when they were not on the decreased temperature. However, when they are going down, we know that the temperature is decreasing. So here on the minus 273 degrees centigrade, their momentum will be 0. Momentum will be 0. Momentum will be 0 on minus 273 degrees centigrade. Means there would be lowest movement. There would be lowest kinetic energy. Just because of kinetic energy too, like kinetic energy here would be 0 as well, as momentum is 0. Alright, so these particles will lose their identity now. Now basically these particles will lose their identity. Let me write this here. Will lose their identity. When they lose their identity, they will be converted to the wave. They will be converted to wave. Now basically these are not particles, now these are waves. Alright, let me make here the waves. This is basically one wave. Here you can say this is particle. Here we have another wave. This is particle. And here we have third wave. This is particle. So now we know that waves have the characteristic of interference. Alright, wave have the characteristic of interference. So these three waves will be unified together. They will be unified together. Wait, let me unify them. They are basically unified together. They are unified, and we have another wave as well. This is unified, and here we have particles of these waves. So basically now these three waves are unified into a single wave. So this wave is what we call the Bose-Condensate. Bose-Einstein condensate or condensate? Condensate. As these three waves are combined together, so this is known as superatom 2, as I initially told you. This would be known as superatom 2. Bose-Einstein condensate is also known as superatom. Now I have told you the reason as well why it is known as the superatom, just because there is the unification of these three waves into a single wave. That's why it is also known as superatom. So now we have completed our Bose-Einstein condensate, which is made with the help of boson atom. Boson atoms are those atoms which which has the even number after an addition of electron, proton and neutron. We take the atoms in the low density as like 3 or 4. Here we have taken 3. When we decrease the temperature to the minus 273.15 degrees centigrade, they lose their momentum. There is zero kinetic energy. With that, they lose their identity too. So their identity is converted then into wave, and basically as there are three particles, so there would be three waves as well. So there the unification happens, interference happens. Those three waves unify together and they then convert it into a single wave, which is known as Bose condensate or superatom. This was the summary. Alright, now we are going with fermionic condensate. Now we are going with fermionic condensate. Now of course, if we are going with fermionic condensate, fermionic condensate. They'll be made with the atoms as well. And what are those atoms called basically? They are known as fermionic fermions. Those are known as fermions. Fermion atoms. Alright. There in the Bose condensate, we were having the low density. However, here we will be having high density. So let me write here this point, which is very important. Here we will have high density, which means here we will have a lot of particles. Here we will have a lot of particles. And density is what basically? It is mass per unit volume. So here let me make the particles, making with green. There are a lot of particles, alright, as we have high density here. High density, high density. Alright, so we have high density here, so that's why I have made a lot of atoms here. Again, we will be giving it a temperature of minus 273.15 degrees centigrade. As I told you, these both states are, can be obtained in the temperature which is very low, which is absolute temperature. Temperature of minus 273.15 degrees centigrade. Alright. So they are on the minus 273.15 degrees centigrade. So now they lose their identity too, as like here they have lose their identity. They will lose the momentum too. Alright, here their momentum will be 0. With that, their kinetic energy would be 0 as well. So kinetic energy 0. Alright, so now as I told you, they will lose their identity too. Now they will lose their identity and they will convert into liquid. They will convert themselves into liquid. Those boson atoms were converted into waves, and this fermions atoms are converted into liquid. Now this is what we call the fermionic condensate. This is what we call the fermionic condensate. Alright, so fermionic condensate is in liquid form. However, we have Bose-Einstein condensate, which is in the wave form. Now I hope this both are clear to you. Today we have discussed about the Bose-Einstein condensate as well as fermionic condensate. So what things were important in this? Let me write here down. Initially, the temperature. They both are obtained on the temperature of 273.15 degrees centigrade. So temperature is very important and it can be only found on the coldest place. With that, we have an other two, like in the boson Bose condensate. We had to take the low density. Alright, low density. However, in the formation of fermionic condensate, we have taken fermions. Fermionic condensate. It requires high density of fermions. High density of fermions. So these two things were very important, and another thing is important as well. Let me write here. They'll lose their identity and they'll convert themselves into waves, and they'll be also known as super atoms. Super atoms. While they'll lose their identity and they'll convert themselves into liquid, and that will be known as fermionic condensate. So this was all for today, as I told you the important points as well.